In this video, we're going to learn about compositions of functions. So first of all, we want to find f of g of 3, given that f of x equals x plus 2 and g of x equals 2x plus 1. So let's write that down again. F of g, that circle there, between the f and the g, that is the composition operation. It's not multiplication. It's something entirely different. So what f of g of 3 means is quite literally f of g of 3. So you just compute the function value of g for an input 3 and then plug that result into the function f. So let's go ahead and do that. So this is f of g of 3. We can compute that by just sticking it in this rule for g. G of x is 2 times x minus 1, so g of 3 is 2 times 3 minus 1. So we just need to compute that and plug it into f. So this becomes f of 2 times 3 is 6, and 6 minus 1 is 5. So f of 5. F of x is just x plus 2, so to get f of 5, we just take 5 plus 2, which is 7. And there we go. There is our value for f of g of 3. Let's go on to the right, find h of k of 0, given the graphs of h of x and k of x below. So this is the same idea. To find h of k of 0, you quite literally find h of k of 0. So we find the function value k of 0, and then we plug that into h. So what is the function value k of 0? Well, that's just the output y value when x equals 0 is the input to the function k. So when x is 0, then the function k hits right here, and we've got the point 0, 2. So 2 here, that is k of 0. So h of k of 0 is really h of 2. And so what's h of 2? Well, let's look on the graph. When x equals 2 here, h is down here. That's the point 2, negative 3. So that means the y value, negative 3, is h of 2. So h of 2 is just negative 3, and there we go. That is the value of h of k of 0. On to the last problem on the slide. Find p of 4, given the function p of x defined by the table below. Alright, so we've got our function p of x, some x and p values here, just inputs and outputs, and we want to calculate p of 4. So really, we want to calculate, quite literally, p of 4. Okay, so what is p of 4? Well, we just look at the table. For the input x equals 4, we have the output p equals 1. So this is telling us that p of 4 equals 1. So we plug that into here and want to find p of 1 then. And p of 1, that's just the output p when x equals 1. So go to our table here, x equals 1, p equals 3. That's telling us that p of 1 equals 3. So that means p of 1 is really just equal to 3. So there we go. There is p of 4. Here's another problem. Given that f of x equals 2x squared plus 3 and g of x equals x plus 1, find f of g of x. Now this is really just the same procedure as we've been doing, but now we carry the whole expression through. Let's write this out step by step. So we want to find f of g of x. And we know that this means quite literally f of the function g of x. But to keep things simple, why don't we just write it as f of g? We'll worry about the x later, but first let's just find f of g. Now we're told the rule for f of x right up here, and this rule just says that whatever we have as the input to f, we take 2 times that input squared plus 3. In this case, our input is g, so we just carry that through in place of x. So 2 times g squared, then plus 3. Now we need to get this in terms of x, so let's go ahead and sub in x plus 1 for g, because that's what g of x is equal to. So we have 2 times x plus 1 squared, then plus 3. And now it's just a matter of simplifying. So let's go ahead and multiply that out. 2 times x plus 1 squared. Well, x plus 1 squared is just x squared plus 2x plus 1. And then we've got a plus 3 at the end. Let's go ahead and distribute this 2 over. So get 2x squared plus 4x plus 2. And then we've got our plus 3 at the end. And combine these constants to get 2x squared plus 4x plus 5. So there we go. There is f of g of x. Here's another problem. Given that p of x equals 3x and q of x equals x squared plus x, find the solutions to the equation p of q of x equals negative 2p of x. So why don't we just go ahead and compute this p of q of x, get a nice expression with just x in there, and we'll also simplify the right-hand side. So first of all, p of q of x means quite literally p of q of x. And that's equal to negative 2 times p of x. To make this nice and simple, instead of writing q of x, we'll just write q. That way it's just like a single letter that we have to plug into p. So p of q is equal to negative 2 times p of x. And what is p of q? Well, p of x is just 3x, so p just takes the input and multiplies it by 3. So p of q is just 3q. Just put q where x was. So 3q is equal to negative 2 times p of x. So negative 2 times 3x. Now we need to get q in terms of x, and we've got this formula right here. Q of x is x squared plus x, so just sub that in. 3 times q, so 3 times x squared plus x is equal to negative 2 times 3x. Now we finally have an equation that we can solve for x. So let's bring it up over here and let's solve it. Let's just write it again. 3 times x squared plus x equals negative 2 times 3x. Let's distribute the 3, so 3x squared plus 3x is equal to negative 2 times 3 is negative 6. Then we have an x. Let's get all the like terms together, get all the x on one side, set the right hand side equal to 0. So we need to add 6x to both sides, and we'll get 3x squared plus 3x plus 6x makes 9x equals 0. And we can simplify this a bit. 3 and 9 are both divisible by 3, so divide everything by 3, and you get x squared plus 3x equals 0. And this can be factored. We can just bring out an x, because that's common to both terms. X times x makes x squared, and x times 3 makes 3x. So x times x plus 3 is equal to 0. We can apply the zero product property and set each factor equal to 0. So we've got x equals 0, and we've also got x plus 3 equals 0. And x plus 3, we can solve that. Just subtract 3 from each side and get x equals negative 3. So there we go. These are the solutions. X equals 0 and x equals negative 3. So now we know how to find compositions of functions. And in the future, we'll continue to learn more about functions, including some interesting functions like piecewise functions and step functions.